value. Follow the steps. Isolate the absolute value. Is it to one side of the equal sign? Make a simple one. Go like this. This is the same as this, right? So you have two roots. This one, when x comes out to be the positive 3. This one, when x comes out to be the negative 3. Therefore, x comes out to be equal to the positive of this, whatever it is. X comes out to be equal of the negative of this, of the whole thing, not the first term. If you only put the negative like this, you only negated the first term. You didn't negate the whole argument. So make sure you put that parentheses there. Now, you've got quadratics, so you have to solve. Subtract x, get it equal to 0. These are your solutions, your roots, okay, your zeros. These are our zeros here. Now, granted this can't be factored, but set it equal to 3, take the square root, and you can come out with a plus or minus radical 3. And you can check those as well. Bring this down here, do this. This one's factorable. And at the end, make sure you check all your roots. Put it in your calculator to check it. Put the absolute value of radical 3, of course, is radical 3. And then put this in your calculator. Even if it comes out with an answer of 1.732, that's radical 3. Put radical 3 in your calculator. And it just has to come out to be the same number. Do you know what I'm saying? If you put this in your calculator, radical 3 squared plus radical 3 minus 3, this should come out to say this, which is the same as radical 3. All you care about is that those match up. That's your check. Your check is just for you to make sure that the roots are working. Then just do second enter, bring it back down, and try another 0 that you have to see if that works. Don't discount them automatically because they're negatives. The negatives will sometimes work. Okay? As long as it doesn't end up to be negative on the right-hand side, you're fine. Okay? This one, same routine. Again, a positive root, it comes out, nothing changes. A negative root, just put the negative in front of it. And then solve them again. And check all your solutions. This one actually had, the 10 was the same, so you just have to check that once. And then the 1 and the negative 1. Use your calculator. Can you all get to absolute value in your calculator? Math, absolute value? Okay. Use your calculator to check those. So what you're going to remember is that your OR statement goes out, your AND statement goes in, like this. We find your solution in interval notation, and because remember, with an inequality, it's more than just one number. If you took your basic statement, this is your just basic inequality, no absolute value. It says from 2 to infinity. You get more than one answer that would fit and make that statement true. So the same thing happens in your absolute value. There are some times that we get no sets, but we'll see those. So if you have an AND, you're going to set that up like an AND statement. If you have an OR, you have to set up two separate statements. You can set your AND up the same way, but instead of the word OR, you put the word AND. You have to set that up with an AND, because otherwise it's going to go like this, and it's going to get all numbers. And we'll see an example in a second. So let's follow an example through. Is my absolute value isolated? Yep. Is this an AND or an OR? AND, because it's a less than, so this is an AND statement. So it's going to go like this. Now, in an AND statement, we can take a shortcut. If this is all nice, we can drop this down and build the AND statement. Come down here, put the same sign over here, and whatever this is on this side, make this negative. If there's more than one term, that has to go in parentheses. God bless you. It's the same as if we made two paths. Let me just show you something. Normally we say, make your positive path, make your negative path. We take this out, we leave this the same, right? We take this out, we make this a negative. What happens when you use a negative with an inequality? If you divide it by a negative, you switch the sign. That would have to go like this. Okay, do you kind of see what's happening? They're going to go like this. They're going to cross. It's going to make us an and statement. Now, I can do this, but I cannot switch my inequalities around. If x is greater than 2, and I want to put 2 on this side, I have to flip that sign around. So if I put the negative 2 over here, I say, flip this sign. You see that piece right here? So what we're doing is building this equation simultaneously. We're building the two sets at the same time when we drop an and statement. You can still do them separate, and I'll work them both out separate for you, and we'll see how they work. But because we swapped this around, it is this piece right here. It fits into that piece. Okay, so let's take a look. Let's do this first this way, and then I'll do it this way, and you'll see the difference. So we solve as if we're solving one equation. We add 5 to both sides. Have you guys solved your ands this way before? Probably in Algebra 2. Okay. Drop it down. It builds your and statement right away. So we come down, and there's our and statement. Now, if we put it on the number line from 3 to 7, not inclusive, there's our and. To go to interval notation, just use your parentheses. Okay. Now let's solve this to see if it's the same thing as when we do two separate paths like this, the positive and the negative. We'll add 5. We'll add 5. So we've got x is greater than 3. So from here on out, x is greater than 3. We have x is less than 7. From here on out, see what happens to an and? They cross. So you have to make sure you say and in the middle. If you don't, then your answer is all real numbers, and that can't work. So this is a little trickier that you have to bring it back together. The only good thing is, because I wanted an interval notation, you're going to have to set the interval up anyway. So as soon as you see this is where they overlap, there's your interval right here. You're going to have to set it up in interval notation anyway, so that's a good way to make sure that they're not crossing forever. Okay, so you basically have the same setup. Isolate the absolute value, make a positive, make a negative. The and we're able to make a little shortcut at. The or we can't, because the ors are going in two different directions. But we can see that this does work, and the little shortcut here is helpful. It doesn't help if there's an x squared and another x that you have to worry about. If you have an x on the right-hand side as well, then you have to do it the long way. Two paths, because you wouldn't be able to work your x's in all three sections. You can't get rid of your x's that way. But is this familiar? Because we do this in Algebra 2. Yeah? Some of it will come back. Some of it you'll start remembering. Let's try an or statement. Okay, an or statement says that my arrows are going to go out like this, a greater than. The greater than goes out. So we automatically start like we do anyway. Your absolute value is isolated, right? It's all by itself. So we're free to do our positive root, our negative root. By positive, I mean keep the one that's there, don't change it. The negative root, we take the opposite. That's what a negative means, takes the opposite. So we bring this down, we leave it just as it is. Or we come down to it on the negative side, never change inside your absolute value, but make that a negative of whatever this argument happens to be. Now, when you use an inequality, if you divide by a negative, don't forget, you're swapping the signs. Okay, and watch, this makes sense if you flip the sign. You see that your signs are both going into the opposite direction? It's building your OR statement. There's your OR. Now solve them. Yeah, it has a fraction. So what can I multiply every term by to get rid of this fraction? 2. Let's multiply every term by 2. 2 minus t greater than or equal to 10. I threw a lot of things in here. Fractions, and we got another little surprise coming up. Now we subtract 2. Negative t greater than or equal to 8. Now we need t to be positive. So what do we have to do? Divide and flip. Good. This is causing this sign to flip. Has nothing to do with our original setup. It's just because when we divide or we multiply by a negative, we have to change the sign. Okay. Now remember, this is an OR. Let's do the same to this side. Multiply everybody by 2. 2 minus t less than or equal to negative 10. Subtract the 2. And again, you're going to flip your sign, dividing by a negative 1. So there's your OR statement. So you've got negative 8. And remember, you don't have to fill in your whole number line, just the 2 critical values that we need. And here's your OR statement. And the last thing you want to do is just build the inequality. The intervals. So negative infinity to negative 8, or 12 to infinity. And this was closed because it had an equal sign. We closed it. You can work both your and your or the same way, because you have to build an interval notation anyway. And so as soon as you put it on your number line, you'll see where they overlap or when they go in opposite directions. You'll kind of see where that happens. Questions on the statement? We give you a segment or an interval, and we have you build the statement. Now, in remembering that the and is a less than or less than or equal to, and the or is a greater than or equal to, that will help you out. And it's a very, very, very basic formula. Both of them are the same formulas, except for the sign here. If it's an and statement, it's a less than or equal to. If it's an or statement, it's a greater than or equal to. So if we give you something that looks like this, from negative 2 to positive 2, and I say, give me the absolute value inequality equation that came up with this. The inequality that came up with this. So you find first the midpoint. In order to find the midpoint, you add the 2 endpoints, divide by 2. It's the number in the middle. It's the average. So a positive 2 and a negative 2, I add them together and I divide by 2. There's my midpoint, 0. And then we need the difference. The difference is the distance from the midpoint to either endpoint, because they're equidistant to your endpoint, right? So the difference between the midpoint and any of your endpoints, if it's easier to go to the positive side, go there. Distance is always measured in the positive. So this is a distance of 2. So then you build your statement. X minus the midpoint, your midpoint is 0. That's in your absolute value. You have an and statement, and they're both filled in. So I have a less than or equal to, and my distance, my difference from the midpoint to the endpoint is 2. Now once you're there, just condense it down a little bit. Get rid of that 0, and there's your statement. Okay, if it's an or statement, it fills exactly the same. If it went like this, we find the same exact steps. Find your midpoint. Midpoint is 0. The distance, the difference here is 2. Distance is always positive. So x minus the midpoint, only now it's greater than or equal to because it's an or statement. Okay? This works itself out. If this is a negative, like say my number line went from negative 6 to negative 2. Say it went here. What's your midpoint between negative 6 and negative 2? Negative 4. So when you do this, x minus the midpoint, there's your negative 4. Less than or equal to, the distance here, always positive, 2. When you take or you subtract a negative, that becomes a positive. That's how you get a plus sign there. So it works itself out. It works itself out where you go with that. Okay? Questions at all?
We have the same worksheet format?
Yeah. It's the rest of the worksheet should be there. And